So guys, have you ever wondered how does the ocean travel from one region to another? Or what could be the underlying factors which determine such movement? If you are curious, then let me introduce you to one of the largest and fastest water moving current, which is the Gulf Stream. The Earth's oceans are connected by a vast global conveyor belt of moving water, a planetary circulatory system that transports heat, nutrients, and sometimes even animals around the globe. And just like our very own circulatory system, the planet's circulatory system is vital to keep the Earth healthy. It influences a huge part of our weather, climate, shapes the entire ecosystem, and even it influences our human civilization. And to our amazement, the engine of this whole global ocean current is powered only by two factors, the temperature and the salinity. To explain this even better, let me take you through and demonstrate this concept in a simple experiment.
To demonstrate this experiment, I have used a flat container and filled it up with fresh water at room temperature. Make sure the container is placed in a flat surface. Simultaneously, I have prepared 2 cups containing water at different temperature. 1 cup is filled with hot water and another cup is filled with cold water. To make it visible, I have added food dye, yellow dye to the cold water and red dye to the hot water. Now gently lift them and place it inside the flat container containing fresh water at room temperature. Remove the thumbtacks and let the waters in the cup to flow into the container. Now, if you observe closely, the hot water rushes to fill the water at the surface level and the yellow cold water sinks to the bottom. This clearly explains that hot water is less dense than cold water. Therefore, it rises and cold water, which is denser, sinks to the bottom of the container. This density difference is creating a current in the small container. Now, imagine the ocean containing a vast amount of water with different temperatures and try to foresee the currents that can be created due to this difference in the densities. Prepare a flat container and fill it up with water at room temperature. Make sure it's placed onto a flat surface. Next, prepare 2 cups and label them, one fresh water and another salt water. On the cup containing salt water, add table salt to make the contents salty. Stir well and make sure all the salt content dissolve. Add food dye to make it visible. Now gently lift the cups and place them into the container and remove the thumbtacks and let the mixture to flow into the water in the container. As you can see, the salt water is sinking to the bottom of the container and the fresh water is filling up at the surface. This clearly shows us that salt water is more denser than fresh water.
Pretty cool, isn't it? You know what's not cool? Climate change.
Human activities has resulted in the increase of carbon dioxide concentration in the atmosphere. The graph shows yearly carbon dioxide measured at Mauna Loa Observatory in Hawaii. The carbon dioxide data on Mauna Loa constitute the longest record of direct measurements of CO2 in the atmosphere. As we can clearly notice, there has been a steep increase in the graph from the year of 2019 to the year of 2023. This has resulted our Earth to warm even more rapidly.
The 2004 catastrophe film, The Day After Tomorrow, portrayed the catastrophic effects of climate change, including superstorms, tornadoes, and deep freezes. In the movie, increased polar ice melting caused circulation in the North Atlantic Ocean to be disrupted, resulting in abrupt shifts in the weather. Scientists dismissed the bleak scenarios depicted in the film, but acknowledged that climate change may impact ocean circulation. However, could it stop the Gulf Stream from circulating? Many ocean currents and wind systems move warm water from the equator towards the poles, and then transports cold water from the Arctic and northern latitudes back toward the equator. These forces make up what's known as the thermohaline circulation. Thermo refers to temperature, while haline denotes salt content. Both of these factors are what determines ocean density. As more water evaporates and/or salt is discharged during the formation of sea ice in high latitudes, the cold water on the ocean's surface becomes saltier. It sinks deep into the ocean and travels through the depths until it can come to the surface near the equator, typically in the Pacific and Indian Oceans. This is because saltier, colder water is denser and therefore heavier. The cold water at the surface is then warmed by the sun, and evaporation makes the water saltier. After being transported northward by the warm, salty water, it joins the Gulf Stream, a sizable, powerful ocean current that is also propelled by winds. After traveling along the east coast of the United States, the warm, salty water enters the North Atlantic region, where it releases heat that heats Western Europe. The water cools down and sinks to the deep ocean once it has reached the North Atlantic and released its heat. The cycle keeps going. The climate of many parts of the globe is significantly influenced by the thermohaline circulation. The Gulf Stream is a component of the thermohaline circulation, which also includes the Atlantic meridional overturning circulation. This ocean circulation system transports heat from the tropics and southern hemisphere to the North Atlantic, Nordic, and Labrador seas before losing it there and causing the colder waters to sink deeply. The thermohaline circulation is dependent on the cold, dense waters that fall into the deep oceans, since it is primarily driven by variations in water density. This can be impacted by global warming, by warming surface waters and melting ice, which adds fresh water to the circulation and reduces the salinity of the waters. This refreshing of the water can stop the cold waters from sinking, and hence change ocean currents. Fresh water is entering the system at an increasing rate as the Earth warms. The amount of melting sea ice in Greenland reached a new record high in 2016. The Arctic loses about 18,000 square miles of ice per day. In May of that year, it lost about 23,600 square miles of ice per day. How does any of this relate to the Gulf Stream, you may ask? The Gulf Stream is the driving force behind the global climate. Its torrential currents move heat and energy from one area to another across the Atlantic Ocean. The system is currently at its weakest point in 1,000 years, and it's going to get worse in the years to come. The repercussions of shutting it down might be disastrous, and the ripple effects would be extensive. Let's explore what would happen if the tremendous Gulf Stream and thermohaline circulation stopped working. Weather changes. A steady climate is largely maintained by the Gulf Stream. Western European winters could become extremely cold due to the slowing Gulf Stream, which could also have a significant impact on Atlantic fishing markets. Whether or not the Gulf Stream totally ceases to exist, the consequences would be disastrous for billions of people worldwide. A new study distinguished between the effects of climate change and the closure of the Gulf Stream. the scientists discovered that the consequences of a hotter climate will be less noticeable overall than changes in precipitation. Although the Gulf Stream is crucial for water circulation, its sluggishness could have a significant impact on weather patterns worldwide. For instance, the climate of Florida is strongly influenced by this powerful warm water stream. It maintains Florida's cooler temperatures in the summer and warmer temps in winter compared to other southeastern states. The Gulf Stream also helps to warm Western European nations, as previously mentioned. Changes in monsoons. If the Gulf Stream is shut down due to climate change, it has been suggested that monsoon patterns may change. If this hypothesis is true, ocean levels along the southeast U.S. would rise by 8 to 12 inches. Additionally, the tropical rain belt may move south, weakening African rainfall patterns and accelerating the monsoons in the southern hemisphere. Additionally, the loss of the Gulf Stream could disrupt the systems that the Earth needs to maintain its ability to regulate its temperature. Changes to the Gulf Stream and its effects on the monsoons would affect a variety of regions across the globe. Along with the Sahel, this could have an impact on the Maldives, India, and Thailand. The monsoon affects the climate of the Sahel region of Africa, which receives rainfall from the West African monsoon as well as the Indian subcontinent. In recent years, scientists have seen indications of the Gulf Stream's collapse. This ocean circulation has been deteriorating in stability over the past century and may stop effectively functioning in a few years or a few decades. The fact that researchers cannot give a definitive timeline is not reassuring. Changes in sea level rise. Despite being self-sustaining, the Gulf Stream system is susceptible to outside influences. The equilibrium has shifted as a result of climate change's warming of ocean waters. The North Atlantic is less salty due to fresh water from glaciers and ice sheets, as well as warmer ocean waters. Due to the decrease in density, the Gulf Stream stops flowing when the water is not dense enough to sink. Sea levels in the United States will rise by an inch every 8 years if the Gulf Stream is stopped. Sea levels are currently lower on the east coast of the United States because sea levels are higher in the waters east of the Gulf Stream, which are warmer and closer to Europe. Sea levels will increase to the west of the Gulf Stream between the U.S. East Coast and the North Atlantic if the Gulf Stream is diminished, because this will cause the temperature gap between the two seas to narrow. In fact, the Gulf of Mexico and the shoreline are experiencing the fastest sea level rise in the United States, and some research indicates that this is because the Gulf Stream has already started to slow down. A spike in the sea level rise from New York to Newfoundland between 2009 and 2010 was linked in other studies to the Atlantic Meridional Overturning Circulation, AMOC, slowing down by 30% during that time, as well as peculiar wind currents that pushed ocean waters towards the coast. It is quite worrisome that slowing down or stopping the ocean conveyor belt could exacerbate sea level rise. So, to sum up, rapid sea level rise on North America's east coast, cooling across Europe that could affect agriculture, a parched Amazon rainforest, and disruption of the Asian monsoon are just a few of the extensive effects of a severe weakening of the AMOC. These are merely the effects that scientists and oceanic experts are confident would occur in the event that ocean currents like the Gulf Stream collapse. The unanticipated effects are what keep those who study this up at night.
Now let's look at the history of the Gulf Stream discovery. It was first discovered in 1512 by Juan Ponce de Leon. He has clearly mentioned a current such that although we had great wind, we could not proceed forwards, but backwards, and it seems that we are proceeding well. At the end of it was known that the current was more powerful than the wind. Was then followed by Benjamin Franklin in the 1768. He became particularly interested in the Gulf Stream, a fast-moving current of warm surface water that sweeps up from Florida along the continental slope of the US East Coast and then bends eastward towards the North Atlantic all the way to Europe. He refers to the Gulf Stream as a river in the ocean. There are two types of water current. Surface current, which occurs in the upper 400 meters of the ocean, accounts up to 10% of the water movements. It moves by solar heating and wind. There is also the deep water current, which we are currently discussing, which covers 90% of the ocean current. Mainly, it is because of the interaction between temperature and water densities. So, what are the other main types of ocean current exists in the world? Let me name a few. To start with, we have the California current. It is cool water from high latitudes flows southward from the edge of British Columbia to Baja. It is also known as the Eastern Boundary Current. It promotes the growth of plant in the sea from microscopic phytoplankton to dense kelp forests. We have the Kuroshio Current. It flows past Taiwan and along the eastern coast of Japan before turning toward the Pacific, a Japanese word that means black stream. That's because the current is much darker than the surrounding waters, the result of lower amounts of organic materials at the surface. Biggest current in Western Pacific. Next, we have the Alguhas Current. It is the surface oceanic current that forms the western boundary current of the southern Indian Ocean. It flows southward along the southeast coast of Mozambique and the coast of South Africa before turning eastward to join the flow from Africa to Australia. It regulates the temperature of Indian Ocean region.